All right, so since this is going to be the first time we're doing this, so now in this class, I like having, like when you're watching a YouTube video, everyone has like a cool intro or something like that, like explosions and like they got to throw their catchphrase in there, right? Yeah, that's only the cool videos, right? So we start this off. So when I say class, you say yes. Class.
Yes.
Class.
Yes.
All right. At least pretend like you're excited to be here. It makes me happy that you could at least pretend that you want to be here. Okay. So now going through here, investigating a limit using a graph. So we're gonna again do the piecewise. So bring up the calculators, what we did yesterday. So we're gonna do it from the left side and the right side. And this is just like what we were talking about on the graph on our warm up today. So we have right here. And I'm going to start with doc B, clear out what I have here. And now got in my scratch pad. And I want this one here, this function. My function is x and 1. X is less than 0. X. And then my argument is x is control equal right there is going to be less than 0. This is 1, where x is going to be greater than 0. Oh, I forgot. Come on, 0. There you go. Alrighty. Again, here is another example. What is the limit as x approaches 0 from the left-hand side? 0. Okay. So my answer is going to be 0. Now, what is the limit as x approaches 0 from the right-hand side? It's going to 1, isn't it? Okay, so again, we're looking at the y values as x approaches. So that's what we're looking at on the graph. So my input value is the value I'm saying that we're going to approach in the x domain, but we're also looking at the y value that that number is going to. That's what I'm looking at. So, does that make sense? Super easy. Now, if I just plug in 0, what's my answer? Why is it undefined? So is it anywhere equal to 0? It's not equal to 0 on either side because of the restrictions I put on it, where x is either less than 0, less is greater than 0, but nowhere is x going to be equal to 0. There we go. So you can't just go in and plug in these to solve these numerically. We have to look at graphs to see what's going to happen here. Or we could do like the calculator building the table to see what is approaching by getting closer and closer to 0 on either side. There we go. Right here, limit. This is here again. So the limit exists if and only if left and right go to the same number. That's what this notation means. The limit exists if and only if the left side and the right side are equal. So now we're going to investigate these limits. We're going to find the limit as x approaches 1, the limit as x approaches 1 from the left, x approaches 1 from the right. Now, do we have a problem with this one right here? Think of just mathematically before you graph any of this. Do we have a problem with this? What's the problem with my domain? It can't be below 1. It can't be below 1, right? So can x equal 1?
Yeah.
Yes, because you could have square root of 0. You could have square root of 0. But can you have below 1? Because why? It would be an imaginary number. So I can't have an imaginary number. So let's take a look at our graph and see what this is going to tell me. I'm going to go doc B again. And I have radical x minus 1. So the limit on this one here, as x approaches from the right, is going to give me what number? 0. Remember, we're looking at the y value. As x approaches 1, my answer is 0. What about the limit from the left-hand side? Is there a limit over here? Is there any graph over here? So therefore, I can say that the limit on the left-hand side does not exist. And the rule about limits said that for the limit to exist, if and only if both left and right go to the same number. So does both left and right go to the same number? Nope. So I could say, graphically, I've shown this one right here, that I do not have a limit because it does not exist from the left-hand side. So if I was going to write this out as a domain type of thing, you could say that I have restrictions that my domain starts at 0 and goes to positive infinity. So I can't have any numbers on the left side of 1. Wait, yeah, did I say 0? I did. Oh, sorry, 1. So my domain starts at positive 1 and goes to positive infinity. It does not exist on the left side of that. There we go. And if you're watching at home, I can't really draw on the board because my smartboard's not liking me right now. So use graph to investigate the limit as x approaches 0 of sine of pi over x squared. Now on this problem right here, what do you got to make sure your calculator is? Radian. Got to double check that's in radian. So go ahead, start that out. So we're going to graph to investigate limit as x approaches 0 of this. So I'm going to graph sine of of pi over x squared. This is what your graph should look like. Anyone's graph not look like this? Alrighty. So what can I say? So we're investigating this one right here. What can I say about this? As x approaches 0,
You put x over x squared, it says pi over x squared.
oh, I did. I put sine over sine of x. There we go. All right. So to fix that, see, I'll check in to see if you're all paying attention. Good job. Good job. You've earned a prize. See, he caught this. Where were you on that one, Tree? Hit tab, arrow up. You could edit. There we go. Now, what does this one look like? Looks like a straight line. Let's change this a little bit. Menu, window, and we're going to change it to a trig window. Trig window goes to negative pi over 2. Yes. Do what?
You did the equation wrong.
I did the equation wrong?
Sign's supposed to be on the outside.
Sine of, you're right. Dang it. See, someone's paying attention too. Sine of pi over x squared. Dang it, man. Tab, arrow up. There we go. Okay. There we go. Now this is better. And I changed this one to trig because the trig window is from negative pi over 2 to positive pi over 2. But what's it look like it's happening right there in that middle? Is that your heartbeat when I said there's a test tomorrow? That's what happens right there? Okay, let's zoom in to see what else it does. So menu, zoom in. As I get closer and closer to 0, what's happening here? Is it still doing the same thing? It doesn't look like it's up. It just looks like it's going up and down over and over again. Now, this is saying that it's oscillating. It is oscillating there. So that one's not going to work out for me because this one is oscillating. So watch this. I'll show you this neat trick. I think you guys actually could do it on yours, but I can't do it on mine. Let's see. And I'm taking the limit. There we go. As x approaches 0, of sine pi over x squared. Dang it, yep. Yours might be able to do it. Does yours do it? You guys actually have the newer version of the calculator, and what's it say?
Undefined.
Undefined. So it's undefined because it is oscillating. It keeps going over and over again, so that means that as you get closer and closer to that number, it's never really going to get there. So it keeps going up and down the whole time. Right here, so I change the window, I increase it, I keep going, and it is going to keep doing this right here. Alrighty, so this is what I'm going to have you guys do. We have, what about like 25 minutes of class left? So we're going to try these out. We got some practice problems here. And we're going to use this time to actually go through and do the assignment. So we can work on homework in here now. So if you need help, ask questions. All right, so how's it go? Speak now or forever hold your peace. There we go. All right. Don't forget, like, share, and subscribe.